Hello, my name's Allan Behrens from Taxal. I'm here with Paul Brown from Siemens, Senior Director of Marketing at Siemens Digital Industries. Hi, Paul.
Hi, Alan.
We're discussing model-based propositions, and today we're talking about the requirements through the process, aren't we, Paul?
Absolutely. Yeah.
We talked about some of the problems. Let's talk about so what do we need to do about this? How can we make our lives easier? So what does one have to think about to actually make a difference?
I think there's a couple of elements to this. There's the cultural element, which is the making sure that the people understand the need to communicate, and then there's the technology element of what technologies can bring to bear. I think importantly, one thing is that companies already have ways of doing this, because the whole idea of managing requirements for a product, in many cases, companies already do that using things like spreadsheets, so they actually have some record. The challenge then is, how do you make that, what do you do about traceability, what do you do about change? So I think that there's both technology and also a level of human process that companies need to think about as they go through this journey.
Right. We talked about companies already doing this, but these are isolated tasks, aren't they? These are often isolated tasks which require a lot of human interaction to keep working and coordinated. And isn't that one of the problems? I mean, one of the problems is we use all these different things all over the place and use humans potentially to interrelate them, which is a problem. Humans make mistakes, let's be honest. So wouldn't it be a good idea to use perhaps technologies or more formal methods of getting this all working together?
Yeah, I mean, that's part of the problem. As I say, some people use spreadsheets to manage things like their requirements, feed that through, but then the connections between the different parts of the chains tend to, as you say, rely on humanware. I mean, at the end of the day, there's people interpreting what's there and feeding that through, which is initially is a fine proposition, but straight away, the minute a change comes through, just being able to trace where a change, a requirement, and all those things. So, and that's what technology can do for you. Technology can do that gluing and connecting the dots and doing all the traceability. For an example, if you think back, we are now at the Euro 6 emissions regulations at the moment.
Right, this is for cars, yeah?
For automotives and in the Euro 6 Eurocap 6 emissions regulations, there's a limit to how much the output on diesel vehicles, which is half of what it was in the Eurocap 5.
Right.
Well, and Eurocap 7 will come out. When that comes out, new requirements. How does a company trace through and say, okay, well, what does that impact? What sort of things are going to need to look at?
Yeah.
Is it, and at the moment they're relying on manual methods. So having a systematic way, bringing technology in to help, and it is a help. I mean, you can't do this just by throwing technology at it. It is where we're looking at. Is how can we connect the dots? How can we connect the dots from requirements through into parameters, into the design system, into simulation? When you look at using CAE type techniques, simulation to be able to analyze and verify against those requirements and keep that loop all together, constantly feeding through.
Right. And one of the other benefits is I mean, you talked about simulation, CAE and things like that, is through a complex product lifecycle. I mean, you're talking about very complex products. They've got huge amounts of options and variants, and they all create their own challenges, again increasing the sort of complexity. But we can have different levels of fidelity through this life cycle, can't we? And that's part of the benefit of this methodology, is being able to manage and allow us to gain insights from these different levels of fidelity.
Oh, absolutely. If you start right at the top level, requirements into a basic system kind of architecture diagram. What do we want all of these different subsystems to do? How do they behave? And how do they play together? Because, and as you mentioned, options variants, you can get situations where, okay, I have a product. when I add something to that product, what's the impact on all the other parts that are affected? Maybe it's heat transfer. Maybe you add something in which generates a heat source. Does it affect everything else? And how are you going to manage all of that without kind of having some help from the technology? And I think that goes back to my point that the world is becoming more and more complex. The more consumer choice we offer, the more option, more people can actually configure to what they want, the more personalization that we have in products, which is everyone is talking about how products becoming more personalized, adds to the complexity that companies have to live in, and tracking requirements all the way through design, validation, and then closing that loop off. Mm-hmm. We are increasingly seeing customers using technologies like the Internet of Things to actually feed back to the start of the process to give information to close that loop off. So that closed loop, and we call it the digital twin, but the whole idea of having a product definition inside of a CAD system, a computer-generated product definition, which is controlled and verified by and managed and updated as we go through. So. Right.
And the other thing is, as not even a byproduct, but as one of the significant benefits is when you do it right and you apply technology correctly, you immediately benefit from instant traceability, improved quality, and to help things like compliance. I mean, medical device companies are big into this type of methodology because it just helps them ensure it isn't a replacement. It just makes sure it's correct.
Yes, absolutely. Yeah. I mean, you get more and more, regulations, regulatory control. You have to prove that you've done the work that you've done, and that you understand the legislative requirements and how they ripple through, and prove that you meet those standards. Yeah. And that's where we're talking about.
Okay. So how do we get going? I mean, how does a company start? I mean, what should they think of?
Well, I think one of the important things is that, look at the processes you use now. As I say, everyone is doing a level of requirements. If you're doing custom products, if you're doing configure to order, if you're doing build to order, any of those all come in with customer requirements. How do you manage that process through, and how do you track it? Try and get an understanding of how you're doing it now and how you're passing those requirements on. Technology, as I said, technology will help, but it's not the magic answer. There's the idea of people like ourselves. We have people that can help out. People can come talk to us about about their processes and how we can help. It's not a case of just let's throw some technology at it. We're also seeing a lot more people coming out of new graduates coming out. The academic curriculums are changing, and you're seeing more and more graduates coming out which understand this kind of cross-domain idea. In the old days, when you used to say, okay, I did a degree in mechanical engineering or electrical engineering, it's more, we're seeing more and more people coming out with a systems type background who understand those crossovers. And so academia is another area where people can go look. Right. And there are regular kind of seminars around this area, around systems engineering. But one of the key messages, I think, is don't get put off by all the terminology. It's actually it's actually what most companies are doing already without all the terminology.
Great, thank you, Paul. So taking it from Paul, who's been involved in this domain for a long time, with some amazing customers, because I've met some of them. It is a complex paradigm to get your head around. I think it's made worse sometimes by the terminology. So keep it simple, rely on people who understand the problems, go to academia. Thank you, Paul, very interesting. I appreciate that.
Thank you, Alan.